This next segment is on hydraulic fracturing and water resource concerns and case studies. Water resource concerns include water availability because of using up to 10 million gallons per well, the timing of water use and the competition from other sectors, water contamination, both from surface water, groundwater, contamination from fracking chemicals, from deep brines that come to the surface, these native waters that are highly saline and have trace elements and radionuclides. My background before coming to the University of Oklahoma is that I was employed by the US EPA in their Office of Research and Development. The last 2 years that I worked for EPA, I was the designated technical lead for their national study on hydraulic fracturing and drinking water resources. In addition to leading the planning effort for the study, I was responsible for investigating reported incidents where it was suspected that hydraulic fracturing operations may have caused impacts to drinking water resources. I evaluated 40 suspected incidents and narrowed that list down to 5 areas where in-depth case studies would be conducted to investigate the source of reported impacts, 1 in North Dakota, 1 in Colorado, 1 in Texas, and 2 in Pennsylvania. A summary of these findings is shown in this next graphic for the 40 sites of these reported suspected incidents. And I divided those up into potential causes based on the information. These broke out into these categories shown on the graphic: surface pits, spills, well construction, water quantity concerns in terms of competition for water resources, treatment or disposal as a source of impact, migration from blowout of a well, and then the presence of abandoned wells that were not properly sealed. In all of these locations, I examined water quality data, other files, and records, interviewed industry, state regulatory personnel, EPA regional personnel, and domestic well owners. The most common risk pathway affecting drinking water for these sites were mismanagement of wastewaters on the surface, from pit leaks, spills, wastewater and chemical transport, and wastewater disposal, and inadequate well construction from poor cement jobs or an inadequate casing job. The EPA national study started in 2010. In 2012, the EPA submitted a progress report, and it indicated that the 5 case study locations had undergone 2 rounds of sampling from over 70 domestic wells, 15 monitoring wells, and 13 surface water samples. These locations were Los Animas and Huerfano counties in Colorado in the Raton Basin, a coalbed methane formation, in Dunn County, North Dakota, in the Bakken Shale, where a well blowout occurred, in Bradford County, Pennsylvania, in northeastern Pennsylvania, in the Marcellus Shale, in Washington County, Pennsylvania, in southwestern Pennsylvania, again in the Marcellus Shale, and the 5th one in Wise County, Texas, in the Barnett Shale near Fort Worth. The EPA case study research approach is shown in this table, where there are 4 tiers, a column of goals, and the critical path to achieving those goals. The first 2 tiers were to verify the potential issue, which I did in preparation for the study, to determine the approach for the detailed investigations, which again, I was involved with. In the last couple of years, others have done tiers 3 and 4, where they've conducted more detailed investigations to detect and evaluate potential sources of contamination and determine the sources of any impacts to drinking water resources. This involves conducting sampling of water, wells, tap, surface water, looking for pathways of exposure, revisiting sites more than once to do follow-up sampling, zeroing in on potential sources of impacts, conducting extensive water analysis, and then trying to develop multiple lines of evidence to determine a source of contamination. Multiple lines of evidence are often called for in these situations because one line of evidence typically is not enough to make a confirmation of a source.